But let's get started. Already, if you've watched me, don't even worry about that portion there. All right. So, what are we going to try to cover? We're going to try to cover a brief history of OBD2 overview requirements, and we'll see what kind of trouble we get into. The whole objective is to get a grasp about OBD and how it can help us diagnose emissions issues. I tried to be funny. I guess it wasn't too funny. Customer comes in, my check engine light is on, and of course, I'm a wise ass, so usually I'll tell them, "Did you check to see if the engine is still there? Maybe somebody stole it." But I don't hear the laughter. But let's go on. So anyway, I see a lot of the blogs, guys. Don't worry, on Facebook and everything. You guys, some of you guys come up with some really nifty stuff. So onboard diagnostics, what is it? It basically refers to a vehicle self-diagnostics. And I highlighted in red, it truly does give everyone access to the status of various vehicle systems. Okay. Brief little history, good old California. Okay, started 1990 Clean Air Act. And you know what? You're going to have it in the handout, so I don't have to. I'm going to buzz really fast for this. By now, everybody knows about CARB, California Air Resource Board, or else shorten it up to ARB. Okay. And back in the day, it required all new cars sold in California since 1990 have some sort of onboard diagnostic capability, and that was your OBD1. And it was a transition. It was better than nothing at all. However, some things like the data link connector were not standardized. You guys remember trying to get those LED lights to give you some flashes and everything else. Along came 1996, and that really was a truly a monumental helper for us guys. OBD2 required in the US for all new cars. SAE-J 1979 established standards for the connector protocols to go along with it. Then, of course, SAE definitely, absolutely is involved. Okay, they rely on them on so many of the standards required for OBD. So you got the J 1979, it defines the specs for light duty. Again, we're still in light duty. However, extended to include light and medium duty trucks starting in my model year 2004. Boy, I spelled that wrong. Staring. Okay. Extended to heavy duty vehicles starting in 2002. No, just so you know, you also got ISO 15031-5. It is based on our J 1979, and it's a combination of US requirements with European OBD requirements for model year 2008. And all you got to do is think about the global platforms that we have going on. So everybody really wanted to get on board with this. So now let's jump into the heavy duty. California OBD requirements for heavy duty engines, vehicles with a gross vehicle weight rating greater than 14,000 pounds. Basically, again, starting a couple of stages. Okay, you got the engine manufacturer diagnostics, EMD. That started with the 2007 model year, requiring a basic diagnostic system referred to as engine. Again, I mentioned that. Then you got the heavy duty OBD2. OBD started in 2010 with the OBD requirements for heavy duty engines. Phase in by 2013, okay, that EMD systems were phased out, and all heavy duty engines offered for sale in California required OBD. Okay. And I put a little note in there. July 31st, 2013, amendment included revisions to accelerate the start date for OBD system implementation, and of course, alternate fuel. We got CNGs, engines, and so on from the 2018 model year and on. Also, it did relax some requirements for heavy-duty hybrid vehicles for 2013 to 2015. But, take away from this, this is a living document, living requirements. They are constantly changing this. And I'm trying to watch my chats over here too, okay? I'm watching the chats here too. Guys, do not be shy. Talk amongst yourselves too if I miss something, because again, I'm always trying to hurry, trying to between work and everything, trying to put this stuff together. That's why a little bit of misspell. But chat amongst yourselves. If you guys see something, or you note something, or you've lived something that was a little different. That's how we learn, guys. We learn from each other. So let me get back on this here. So heavy duty OBD applies to diesel compression, of course. How about spark ignition? Look at all the heavier trucks that you have that you still have spark ignition, and that was fully phased in all engine families by 2016. And of course, I mentioned alternative fuel and hybrid vehicles. The bottom line is we get involved with the diagnostic portion of it as a helper, but more so the manufacturers, okay, they're the ones that are responsible to meet these requirements. They must provide a very detailed testing result and documentation to show they comply with OBD requirements, get certified. And I don't want to get into it, but the manufacturers they're constantly being followed. They're making the feds, they make sure that they're doing what they're supposed. And again, not to mention, but you guys, you watch the news, you know all about, how some of the manufacturers, they kind of failed on those ends, and then the fines get awful, awful hefty. But back to California Air Resource CARB, or often referred as ARB, I mentioned, they truly have been instrumental in involving, ARB has followed a process revising OBD rules for vehicles, roughly, I'm saying between every 2 to 4 years. For heavy duty, of course, CARB completed the rules 2006, first compliance 2010. Again, it pertains to the engine families of each manufacturer, and they started slow, but eventually, if you read in between the lines, by a certain date, all the engine families have to comply, Now, why heavy duty OBD2? Of course, the obvious answer would be emissions. But you would think that the existing engine parameters diagnostics be enough to accomplish a goal. Even though, and those of you that get into your scan tools and stuff, you got thousands of parameters and they're defined by J 1939/71, and 1939, just so you know, and I'll get into that, is a master, but there's so many other areas that different families that define a lot of the separate areas that belong with J 1939. So again, 71 serial control communication heavy duty vehicle network is the way you want to look at it. And we have DTCs and over 50 diagnostic messages defined in that J 1939. And now I jumped into that 73. There was that missing requirements to monitor powertrain emissions control performance to meet regulations. So basically with OBD, what are we concentrating on? We're concentrating on emissions performance, okay? Heavy duty requires monitoring of all major emission control systems, detect malfunction prior to emissions exceeding thresholds, requires that after treatment devices, the TPF and NOx reducing catalysts are monitored, failures are alerted to the driver. Requires that all emission-related electronic sensors, actuators are monitored for proper operation. Okay. So my question always is, and then of course, I'm sure all you guys, if you get into this, who really is in charge of OBD regulations? Okay. The best way I can explain, I guess, is EPA and CARB. They establish OBD standards requirements. Perfect example is in 2008, EPA granted a waiver from federal preemption to the state of California, allowing to establish and implement heavy duty OBD. So I guess both of them work closely together. Third option is, and this is something a lot of guys do not know, is called what worldwide harmonized onboard diagnostics. The goal is to coordinate the light duty and heavy duty OBD reporting and enhance the information provided. Implementers may choose any of these options to meet OBD requirements unless specified otherwise in government regulations. As of now, to be honest with you, vehicles sold in the US, they can use any of these 3 OBD options. So why would I even mention this? Just so you know, we're in heavy duty. Volvo Trucks uses that worldwide OBD as a common approach for EU and US. And again, think about Volvo. I mean, huge all over, right? They're a global company. The requirements, OBD regulations have the following 4 main areas of requirements. Powertrain diagnostics, design, development, operator service, testing for certification, and post-production. Now, for us guys, the most important requirement for us is the first one. It actually deals with the monitoring for malfunction of sensors, actuators, controllers, and again, systems, emissions, and or performance. Required for the engine, after treatment, transmissions, and now also hybrid systems. Okay? So a certain section of the requirement I buzz right through whenever I do the research. You know what? I'm not the guy doing the manufacturing engine. I'm more interested in what pertains to me. Okay? So the heavy duty has approximately 124 constantly changing. Of course, I mentioned the changes, required component system monitoring requirements. In addition to 124, there is a comprehensive component monitoring. Comprehensive component monitoring. Guys, again, if you work on cars all your lives, especially your older guys, some of this stuff comes awful familiar, should sound awful familiar to you, you know, because we're almost mirror imaging what the car industry has. So for example, what are you trying to do with the comprehensive component monitoring? Each input sensor has 6 monitoring requirements. Each actuator output has 4 monitoring requirements. And that's what I was talking about. It's not like saying, hey, you got a temp sensor problem. What portion of it? What is the problem with the sensor? And that's where OBD has been very, very valuable for all of us. You know? Second main area, okay, the malfunction indicator lamp. That is amber, and it is an engine icon. So far, so good, okay? Just like you got in your cars. Standard diagnostic tool connector, just like you got in your car. You got the 16-pin. Standard protocol with hundreds of parameters of messages to service providers. That's us, guys, with information that the OBD system must support, such as live data, historic data, drive cycle data. Okay? The 2 other previous mentioned areas, like I said, they're manufacturer requirements, okay? Another major requirement OBD is to allow access by the manufacturers to service information and service tools available to independent repair shops and fleets. And to me, that's been a game changer for years, guys. You know, granted, you might pay for services through your J-Pro or whatever you guys are using, you know, but however, it does open the door. It did open the door to allow so many of us to get at that information. Okay? Some heavy-duty OBD changes since October 2019. New heavy-duty diesel engine after treatment monitoring requirements, complex NOx monitoring. I did all that stuff with emissions the last 3 months. And boy, I got to tell you, this is why. You know, this is where it all comes down to, you know, why do we have this, especially OBD, emissions, okay? Additional data tracking, such as now you're going to get, if you were able to get in there, okay? They're telling the manufacturers, you better have in there engine runtime, idle time, PTO time, runtime with no reductant delivery, and runtime with exhaust temperature below 2. If you think about this, that's a lot of information, okay? And if we can tap into that kind of stuff, you know, if you've got regen problems and everything, that's some valuable stuff we can utilize. But anyway, this was a summary basically of what OBD is about, you know. And again, like I said, I could spend hours and hours on this. So let's start into shifting away a little bit more on the specifics. You got the MIL and fault code requirements. Onboard diagnostics for OBD2 is incorporated into the hardware and software of the vehicle's onboard computer to monitor every component that can affect emissions performance. Each component is checked by a diagnostic routine to verify properly functioning components and systems. If a problem is detected, okay, what's going to happen, guys? You know, you're going to have that you suck light come on, that warning light. This light will typically display the phrase check engine or service engine soon. System will, of course, store important information about the detected malfunction. And this is the area I want to get into. And that information is very important so a technician can accurately find and fix the problem. Of course, here's your lamp, okay? Located on the driver's side instrument panel. It will come out for a bulb check. So far, you guys are so used to this. No different than an ABS lamp. It goes through a bulb check and so on. And the requirement is that it has to illuminate at least 15 to 20 seconds. It will stay illuminated when the OBD system detects confirms a malfunction that could increase emissions. So far, good. Now, let's talk about lamps. So you're going into the vehicle, you hop in there, you turn on the ignition key. Whoa, all of a sudden, all these different bulbs and lamps, and it lights up like a Christmas tree come on. So I figured let's take a little slow walk down that lane here. Okay. Not all lamps are specific to emission fault codes. That is why heavy duty OBD equipped engines can have both the OBD and non-OBD fault codes. Typically, you got a non-OBD fault code that'll illuminate either the amber warning lamp, or you guys know you got the red stop lamp, okay, typical of Cummins incorporated dash lamps. So now the OBD faults will always eliminate the MIL. However, in some cases, the amber warning light or the red stop lamp are also illuminated as well. That stop lamp doesn't mean that your stop lights didn't come on. Just kidding, guys. Okay? Actually, maybe that's not a bad idea. Go in the back, make sure your stop lights came on. But anyway, malfunction indicator lamp is yellow in color, is the image of an engine. Then when you get in some of these vehicles, you got the amber warning lamp. Amber in color can either be the image of an engine featuring a wrench, or can be the text check or check engine. Amber warning lamp is used to indicate a non-OBD fault code is active, or, of course, why do we have the wrench? You got a maintenance condition exists. And ultimately, you got the red stop lamp. Red in color can be the image of an engine featuring an exclamation, the outline of a stop sign featuring the engine, or the text stop or stop engine. The red stop light is used to indicate an engine protection fault code or engine protection fault exists. So I took my time, make sure that's in the handout, because that does happen quite often. What the hell am I looking at here, man? I got all these lights coming on. Stop the engine. There is a critical issue. And of course, I know you guys, if you have to answer some of the service calls, next thing you know is, engine is blown or something. And the next call is, oh, I'm hearing a knocking noise or whatever in the engine. Well, what happened? Well, this red light came on and I thought I could make it to the nearest truck stop. Been there, done it. So little education of drivers is important, EMD one engine family. The EMD was always on, but the OBD required, it went into stages in the day. It went into a stages, I believe it was like 20%, 50%, and finally everybody had to get into it. So, and I'm going fast, but that's a good question, Jim. Yeah. So vehicles using SAE J1939 protocol, the following was happened before. That question with Jim that had to, I've noticed throughout the years, especially when CARB gets involved, when heavy duty got into all this stuff, they were I'm trying to be diplomatic. I could go way, way, way back. This won't take but a minute. I remember cars went into OBD2, got into electronics. And, Jim, you probably remember more than anybody else. When we went from carburetors to electronics and all this stuff. Well, heavy duty didn't go there. We stayed mechanical. So I'll never forget when that little bit of kind of word got out that, heavy duty has to go electronic too, get away from the mechanical. And all you heard in the day was, this is BS, it ain't never gonna work, blah, 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 blah. And when they finally went electronic, all of a sudden the whole industry woke up. It's like, wow, my engines are running clean. wow, I'm getting more miles per gallon than I ever did before. More miles, meaning if you went up a fraction of a gallon, it was a lot. But you figure 3,000 miles a week, it starts adding up. Well, and then all along, every time something else comes up, and California was kind of pivotal in pushing that. California says, well, by the year, blah, 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 you should have this. Everybody's got to do this. And of course the feds typically went along with it, but the industry looks at it as every time we make a change, it's a huge cost factor. Every time you require the industry to do something, it's going to cost money, 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 money. So to make it happen once in a while, to allow the manufacturers time to incorporate a lot of these requirements, they allow them to go in the engine family, kind of like okay, you show us that you got 20% of the engine families coming off the assembly line, they will meet the requirement. But however, next year it has to be 50%. Next year, blah, 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 100%. And that's the way the system works out there. And guys, you're going through that with the electric vehicles right now too. That for the last few years, all you heard was the 2030, 2030. Well, this does not mean when the year 2030 comes out, every vehicle has to be electric. It's all done in stages. So, but anyway, first time a function is detected, you're going to get a pending code and freeze frame. It's going to be stored within 10 seconds. At this point, it has not matured into current code and the MIL is not on. Okay. If the malfunction is detected again before the next driving cycle in which the suspected component system is monitored, MIL will be turned on continuously. This time, a confirmed fault code is generated and stored along with a freeze frame or engine data. And this is why when you get into your scan tools, you see the pending, you get the matured or active codes and all that stuff. But that freeze frame is so huge. That's one of the requirements, and I'll get to freeze frame in a second. If a malfunction is not detected before the end of the next drive cycle in which monitoring occurs, the corresponding pending fault code shall be erased at the end of the driving cycle. So that's good information, guys. If it hasn't matured, you know what? But if you can get in there and look at that kind of stuff, it kind of gives you a kind of like a historical snapshot. Oh, there was a problem, but you know what? It didn't go to the next step. Or maybe I caught it while it was a pending code and my fix didn't allow it to go that far, and it just goes on again, except for misfires and fuel system faults. If malfunction is not detected in the next 3 drive cycles, the MIL will be turned off, but the trouble code will be stored for at least 40 warm-up cycles. And that's nice too. It allows us to go back. This guy's coming in with a problem. He ain't telling me kind of like everything that happened. Maybe it came from some other shop. Maybe the guy tried to fix it themselves. If you go in there and you get that information, you say, hey, wait a minute. This guy's had some ongoing issues with this vehicle, And those of you that work and run shops and work on that kind of stuff, I find that customers sometimes are a little reluctant to tell you the whole truth, because if they tell you the whole truth, it's kind of like jing, 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 jing. The more I tell you, the more it's going to cost me. Well, it's totally opposite. The more you tell me, the more history you give me, man, it's going to cost you less because I can start figuring a game plan. So anyway, this is the big one here, the freeze frame. And I know when G does car portion of the OBD, he emphasizes it. I've done some webinars for him, same thing. All you trainers are out there. You will always mention the freeze frame as part of your diagnostic routine. Trucks no different. For 2010, 2015, OBD system shall store and erase freeze frame conditions in conjunction with storage erasure of either pending or confirmed. 2016, subsequent model year engines, OBD system shall store freeze frame in conjunction with the storage of a pending fault code. So again, you're gonna have the handout, and if you choose to use this handout next time you work on something to figure out, how can I get the information stuff, go back to this. I'll be very honest with you. the lunch and learns, it's fast paced. It's very fast paced. But I've actually had people call me and send me emails say, "Hey, you know what? You just saved my ass. I went back on that handout because I couldn't remember this. I couldn't remember it was a DOC first, and then the TPF was a TPF first. I was looking for sensor stuff like that, and that's what this is all about." Okay. So if the pending code matures to a confirmed active fault code, the OBD system shall either retain the currently stored freeze frame condition or replace the stored freeze frame conditions regarding the confirmed active fault code. The OBD system shall erase the freeze frame information in conjunction with the erasure of the confirmed fault code. Okay, so bottom line is you get a fault code, get in that freeze frame, do not erase, do not clear anything out till you have all the information that you can. I don't care if you write it down on a piece of paper, if you're on a scan tool, if your scan tool can have the memory to retain it, take a picture with your camera of that little prompt there, because that information there allows you to have some good detective type of information. Okay, not to mention once you repair that vehicle, hey, this particular issue happened, this fault happened when I was doing 40 miles an hour, when the temperature was this, when the load was this. And if you truly want to make sure that you fix that vehicle, duplicate that condition. Let the computer put it out and you can't go wrong. There's nothing worse that you think you fixed something, you clear the code, and out goes the vehicle. And this is why G has coined it, the "you suck" light comes back on, the customer is coming back. It's like, gee, I just had it in your shop, So no, the freeze frame info can also deviate, and it can, dependent upon allowed alternate strategies that store both a pending and confirmed fault code and eliminate the MI upon the first detection. So basically, they also give the manufacturers a little bit of a leeway. Okay, you show us everything you're trying to do with that OBD. Okay, so you have an alternate strategy. We'll decide if this works or not. If it works, you can put it in a requirement. Okay. And here it is. The OBD system shall store race freeze frame conditions in conjunction with storage erasure of confirmed fault code. This is an except. If a fault code is stored when the maximum number of frames of freeze frame condition is already stored in the diagnostic or mission critical PCM, the OBD system may not replace any currently stored freeze frame conditions control unit for the newly stored fault code. So now, hey, time flies by, guys. Time flies by. 2023 was just last year, a few months ago. Through 2026, if a misfire fuel system fault code is stored when the maximum number of frames of freeze frame condition is already stored in the diagnostic or mission critical PCM, the OBD system may replace any of the currently stored freeze frame conditions for fault code in the control unit with the freeze frame conditions for all fault code as allowed for gasoline, diesel, misfire fuel system models. And like I said, if you choose to, mull over this, get into what, there's a lot of information about OBD2. And I'll be very honest with you, a lot of the stuff, you get some good stuff, I see Gene over there, plus always run the monitors, check the mode 6 after repairs, absolutely. But also, there's a lot of information out there, So let's do a quick summary. Freeze frame is stored for at least one DDC. Freeze frame can be overwritten with a higher priority fault code. Freeze frames are usually erased when the DTC erased. And this is, I'm being general here, guys. I'm being general here, okay? The important concept, don't erase a fault code before looking at freeze frame. Why? The freeze frame data, again, this is a reminder, provides critical engine parameters when a fault appears that stores a DTC. What can it show you? It can show you a lot of stuff. I just put a few things on there. The description, engine speed, engine temperature, load. Again, information freeze frame, it can help in pinpointing cause of a failure or at a minimum, narrow your search. Also provides us with a similar condition window to duplicate the conditions to verify repair. And reminder, these are OBD requirements that allow you to go in with any scan tool to retrieve generic OBD required info. And by the way, no different than cars, what you see on OBD tool on a heavy duty, that's all true values. They're not default values or anything. So that's always helped us out. And that's why I always, if on cars, we always keep saying, go on the generic side first of OBD, go in there quick to get what you want. And then, of course, once you try to figure that out, if you need to, then you go into your enhanced or, your OEM tools, but just try it once in a while. Just, go into that area. Monitoring, various monitors run during a specified trip or drive cycle, determine proper operation component system can affect emissions. Monitoring occurs under conditions that are encountered in normal driving conditions. BS, just kidding. That's just those of you that have had to run monitors on cars and stuff, it's not as easy as it sounds. I mean, you got vehicles out there, it's like, holy moly, customer, do me a favor. You go out there, drive that vehicle for 3 days, do this, do that. Come on back, I'll put my scan tool on and we'll see if the monitors have run. But anyway, much effort is spent in avoiding false passes, false indication malfunction. Monitoring should occur at least during one vehicle trip in 10 for 2013 later. There are two types of monitoring: the continuous, usually misfire and fuel related. And again, there's much more better information, I'll be honest with you, on the automotive side, because there's so many trainers out there, so many people that have really done a good job with this. And you got the non-continuous comprehensive specified components once per year. But the bottom line too is we're a little kind of quick into hitting that clear button, and everything else. And I don't know. For years when I was doing a lot of automotive stuff, I would tell the guys, you know what? You do your repair, drive the vehicle. Let the computer decide if that repair was proper, if it did the fix and whatever. Because I'll be very honest with you, if it runs those monitors and you don't have no check engine light come on and everything, and you go in there, everything's run, you know what? Pat yourself on the shoulder. You did a good job. Documented. And this way too, if the vehicle comes back in a week, 2 weeks, 1 month, you got it down there. Wait a minute. The computer actually verified that I did the proper fix. Okay. Misfire monitoring. OBD system shall detect a misfire. Misfire is huge. Doesn't matter if it's on a diesel or whatever the case may be, because when one or more cylinders are continuously misfiring, additionally, it doesn't have to be spark. Right? Anything that can cause a cylinder to do misfire, lack of air, all sorts of stuff. Okay. But for now, for 2013, 2015, year engines, again, it's not vehicles, it's engines equipped with sensors that can detect combustion or combustion quality for use in a homogeneous charge compression control systems. 20% of 2016, 50% 27. And here we go again, the phase-ins again, okay? 100% for 2018, subsequent model year. And again, the reason you have those phase-ins, you're trying to please a whole big industry out there, and you want to give manufacturers enough time to work out all the bugs. The following are monitoring conditions, 2013 through 2019 model years, under positive torque conditions between 2975 of peak torque with engine speeds, 75 of maximum. So let's stop here for a second. So if somebody tells you, this is when I want to monitor this, just think about the positive torque condition between 2975. If that vehicle's sitting there at idle, are you going to get any misfires or stuff? No. This information tells you what? You need to go out there, get a little bit of a load on, get some speed up, and so on and so on. Oh, now I see the misfire came on. You sit there all day long in idle. So you need to know that kind of information. Again, for 20% of 2000, diesels 50, 20, 20, and so on, engine operating conditions. So bottom line is I'm going to move a little bit fast to make sure we get through with everything. Would you have known about this condition to duplicate for misfire? Should you know? Is it easy to find misfires on diesels? You guys that work on diesels, not really, right? Scan tool bidirectional. This is like, does your scan tool good? That all helps out, guys. You know, if we can get into cylinder panels, fuel injector balance, and so on. And I asked a question about idle. And keep in mind, you need to know what is the computer looking for. That's your key to everything. If you know what the computer is looking for, then that's what you should be looking for. Heavy duty OBD, real fast. Some examples. These are just examples. Fuel system. What's it going to look for? Fuel system pressure control, injection timing, feedback control, injection quantity, misfire, detect continuous misfire, determine percentage of misfiring cycles per 1,000 engine cycles. And, you know, I mean, I can go on and on. Of course, don't forget, diesels definitely with EGR, low flow, high flow, slow response, EGR cooler operation, catalyst performance feedback. But stop and think for 2 seconds. This is all information that you can have access to because it's looking at all those different areas of the systems. Okay. Oh, here we go. Here we go. Okay. Heavy duty OBD standardization, standard data link connector, standard protocol for communication with a scan tool. Engine manufacturer must provide the aftermarket service repair industry mission related service. So far, this is great, guys. This is great. Standardized function to allow information to be accessed by a universal scan tool, just like cars. It's great. These functions include readiness status, data stream, freeze frame, fault codes, test results, and so on. And by the way, that's why on the car side, just think about it. You can go out there, get scan tools that cost $30 upward into thousands of dollars. Because what are you doing on the cheaper end? You're going to get into all the OBD information. Okay. So now, that's why I said, here we go. Data connectors. We've gone through a few little changes, guys. Also referred to as diagnostic link connector, DLC. They're used to connect the electric service tool, okay, to the vehicle's electronics. Now, the older systems, we had the J1708 data connector, used to access J1587 data bus. 6-pin, Dutch connector. Various communication protocols are used in transmitting data such as vehicle data, diagnostic information. This 1708 was a common protocol back in the 1990s and early 2000s. But it's all about speed, guys. I believe that had like 250,000 gigabits. We're up into 500,000, you know, since we went to J1939. And that's why I said it's all about speed. So OBD legislation, other factors led to changes requiring trucks to use that 9-pin or not get to that 6-pin, 16-pin OBD port. Okay, and you see the older speed there. Now, this is the one most likely that all you guys are using, you know, unless you're working on older vehicles still, which I do. Okay, this is a J1939 connector. Okay, there's 3 types available. You still have the black 9-pin, and then you got the green 9-pin for EPA model year 2013 and newer. However, I mentioned the 16-pin. You got the J1962 16-pin Volvo Mac. They came up with that, or they decided we're going to use that back in 2014. We're talking about OBD here. Okay, OBD. Now, what happened, if you see, I put an arrow there. That one here has a reduced, and it's the F cavity. The next slide, I'll show you what the F is and everything. It's to prevent cavity to prevent design to block access to older black version connector. Okay. The first generation, it'll make sense in a second here. J1939 incorporates the 1708. I'll stick with 1708, which may or may not be used, but you have access to it. The second generation is green in color, has a reduced F cavity. You'll see the next slide, to block access by the older black version. Okay. Volvo Mac opted to make the 16-pin automotive assembly line diagnostic link their data connector from model year 2014 on. And we'll put it into perspective here. Okay. So here, in case you wanted to, here's your pinout here. I even threw that in if you ever wanted to go in and back probe and see, look at your CAN issues and everything else. No, the post 2013 Korean color 9-pin is backwards compatible with pre-2013 receptacles. A smaller F-pin cavity on the green receptacle is designed to block access by a black pre-2013 plug. Okay, you don't want any issues. So, I kept saying, and everybody's heard the J1939, J1939, J1939. What is it? It's from SAE. Okay? It's a communication network that is a high-speed ISO 11898. Oh, CAN-based communication network supports real-time closed-loop control functions, simple information, diagnostic data exchanges between the ECUs, and physical distributed throughout the vehicle. Just think about this. You can typically your truck here, okay? Think of all the major manufacturers are involved in that truck that you're working on, okay? Meaning their components and so on. You got different truck manufacturers, you got different engine manufacturers, you got different transmission manufacturers, you got different ABS manufacturers, different other component manufacturers. They all get put into a vehicle at any given time. Was not to mention, you're the customer, the one that wants to buy that truck, can spec a lot of these different components to that vehicle that they want. I'm not happy with that rear end manufacturer, so I want mine with this, and so it goes on and on. They all need to communicate to each other. Your scan tool actually becomes another part of this communication network the minute you hook up to this system. So 1939 is really a standard. It does consist of 16 companion documents, okay? And 1939 is the master. It's the master control for defining so many of the different applications, and I'm not going to get into it. But those of you that have been working on these vehicles for years, there's an example. This document provides a comprehensive list of assigning data parameters, diagnostic identifiers, and if you guys get into materials, you'll see the SPNs, PGNs, okay, and all assignments for name. Note that 39 was developed for use in heavy-duty environment, but just so you know, 1939 communication network is also applicable for light-duty, medium-duty, and stationary. How about off-road vehicles? What's the benefit of using 39? I'm shortening that word. Connecting the vehicle electronic systems to one central network, enhancing vehicle monitoring and management. Because they are all connected to one vehicle network, the vehicle system becomes more serviceable. And that is the benefit of having a J1939. Okay? Developers, they're expected to design their product to the SAA recommended practices. And it also enabled the manufacturers the ability to customize communication. So we mentioned CAN. This is not a course on CAN. I'm thinking of doing one. Well, let's put the 39 and CAN together. J1939 uses the CAN protocol, permitting any ECU to transmit a message on a network when the bus is idle. Each message uses an identifier defined. So if you've never gotten into CAN, just look at this as being kind of like a little bit of, so that's what CAN is about. The message priority, from whom it was sent, the data contained within it. Then you have an arbitration process that occurs while the identifier is transmitting, resolving collision. We don't want like, holy shit, everything's, excuse my French, is coming together and they're colliding. No. Hey, this guy's got more priority. Let this guy through. But we're going to let this guy through very, very fast, okay? It's about speed because of equal access on a network for any ECU. Just think of all the ECUs involved in today's trucks. So bottom line is the highest priority message prevails, okay? CAN systems enable the use of a single command station, master to control diagnostic systems, receive information such as emission level, right? Brake transmission flow, fuel efficiency, anything else you can think of that relies on electronics. Okay? So when you do put them together, you're going to have reduced wiring. CAN requires only 2 wires between the nodes. Easy implementation. collision-free bus arbitrage. This is where my pressure gets up. It's like, holy shit, it's like 10-1. We got to get rocking here. Reliable communication, improve service capabilities, improve maintenance, error detection, fault confinement. Okay. Here's an example of the family that belongs with J1939. Here we have 82, compliance. The purpose of these compliance procedures is to generate one or more test documents that outline the tests needed to assure that an ECU that is designed to operate a node on an SAE J1939 network. 84, OBD2 communication compliance test cases for heavy-duty components. Recommended practice, verified vehicle. And you have it in your handout, but the bottom line is you'll see all this J1939-71, J19, like in this case, 82, 84, and I believe there's like 18 in that, 16 in that family. Now, 2017 saw the introduction of multiple CAN channels to compensate for the increase of sensors and ECUs. So for example, one CAN channel for powertrain components. You might have another CAN channel for everything else, just whatever comes into your head, radios, body controllers, and so on. CAN 1 has been used typically for the powertrain. 2016, Peterbilt, Kenworth, and Volvo moved the powertrain traffic to what they call CAN 3. That is why the normal 9-pin connector would not work. One way to overcome this, and depending on your scan tool, everybody stays up on top of it. We were able to purchase what we call a CAN 3 to CAN 1 crossover cable. Okay? And it came down to that F cavity. So I'm just throwing stuff out there. Now here we go. Which plug should I use? Okay. Mac and Volvo use the 16-pin OBD2 plug. Okay. But they also added the 9-pin to allow repair facilities without the means to connect to the 16-pin configuration to connect to Max and Volvos with Cummins engines and diagnose the truck with the 16. Again, you got to mix match it. Max, Cummins engines, like we had in the previous slide. The problem is that the 500K 9-pin doesn't always read the entire vehicle and may only provide diagnostic information from the drivetrain. Unfortunately, we're creatures of habit. So again, which plug do we go first? Yes, the 9-pin. You will get the engine information for diagnostics, but fail to find issues related to the truck. Get in the habit of connecting to the 6-pin to identify all issues. And again, if you didn't read into this, if you're like me, you're going to go grab your scan tool, and all this time you're working heavy duty trucks, what are you going to grab? You're going to grab the 9-pin. But in the case of Mac and Volvo, get in the habit of get that 16-pin, if you want all the input. Look, it's also possible to have an MIL on condition diagnostic trouble code stored in memory of an OBD vehicle computer. And of course, the vehicle seems to run you guys know, it's like, my check engine light is on, but I feel nothing wrong. It runs like a champ and so on. And you get that out there. I know all you guys get out there. Just a little reminder, that light is on. That means there's something is wrong. I know we try to please the customer, or maybe you get busy in your work and you're piled up with vehicles coming in. I just run it for a while, maybe it'll go out by itself. I'm preaching to choirs. You guys know what I'm talking about. Every day that goes on, including in my shop, OBD is designed to detect deterioration of system performance that can result in increased emissions. Because what you don't want is don't want to let something go where it winds up being also something that doesn't happen with the cars really. Is when that big truck goes into D-rate, and now all of a sudden you get that call, man, I can only do 40 miles an hour, blah, blah. I'm on a hot road out there and everything else. And it's like, well, how long has your light been on? Well, it's been on for a while, you know the story. OBD key points. Okay. Rationality test, testing sensor inputs, big part of OBD. OBD compares sensor input for accuracy while in the range of normal operation and to another input. So it makes sense. You don't expect a map. You're just using it as an example. You don't expect a map sensor indicating a high low condition when the throttle position sensor is indicating closed throttle. Okay? So this is all a learning curve. OBD2 allowed us to think about those kind of strategies. How do we derive at these codes? You know, monitors software programs inside computer test component subsystems, enable criteria, a set of vehicle operating conditions needed to run them, and that's we're back to the same thing. Wow, I keep driving it, then I can't run this monitor at all. Well, you didn't meet to what? You didn't meet the enable criteria. Okay? Each monitor has its own set of enabling criteria. Monitor will not run if specific criteria is not met, you know. And this is just an example. You got it in your handouts, go through it, you know. 3 types of continuous monitors, comprehensive, okay? Constantly checks various sensors, actuators, see if they're functioning properly. Okay, sensors are compared pretty near any sensor, and whatever you got under falls under the comprehensive component monitor, which is great, you know. Don't forget sensor input that doesn't make sense. Rationality, besides checking for shorts and opens. Fuel monitor looks for excessive fuel correction problems, other fuel problems. Misfire, of course, just like the word says, look for misfire. Okay, they'll detect misfire, 1 or more cylinders. Okay, to the extent possible, without adding hardware for the specific purpose, the OBD system shall identify the specific misfiring cylinder, which is nice. What is a drive cycle? Driving conditions satisfy enable criteria. Let all the monitors run. Completion begins with engine start, engine shut off, and so on. Begins at the end of previous hour, begins end of previous 4 hours, and so on. For monitors run during engine off conditions, the period of engine off time following engine shut off and up to the next engine start may be considered part of the drive cycle. Again, for vehicles that employ engine shut off strategies that do not require the vehicle operator to restart engine, continue driving hybrid buses, for example, with engine shut off, manufacturer may request. So again, if something changes, they want a little bit of different strategy, they can approach CARB and EPA, say, hey, you know, this is what we want to do. So general requirements, OBD system, malfunction is present, system will detect malfunction, store pending, confirmed MIL, and so on. We walk through it. I'm going very fast. Shall be designed to operate for actual life on an engine, which is important. Okay? May not be programmed or otherwise designed to activate based on age and on mileage. And this has gotten a lot of the manufacturers for years into trouble over here. So that's why I threw it in there. Computer coded engine operating parameters may not be changeable without the use of specialized tools and procedures. MIL fault shall be located driver's side. We already went through it. Amber in color when illuminated. The ISO engine symbol will be displayed. Only one MIL shall illuminate and a key on engine position before engine cranking to indicate MIL is functional. MIL could be used at the manufacturer's option to indicate readiness status. And again, following the chart, you see what's going on here. It's in your handout, okay? And just extinguishing for fuel system misfire evap, once the MIL has been illuminated, may be extinguished after 3 successful driving cycles, indicating no malfunction. And of course, you can erase a confirmed fault code. Code will be erased if the identified malfunction has not been detected again for at least 40 engine warm-ups. Erasing permanent codes, OBD system itself makes a decision, erases it, you know. Now, clearing fault codes does not fix the issue. I am slowing down on this slide. Look at everything pertaining to a fault issue, conditions for setting code, running the diagnostics, action taken when fault code is active, conditions for clearing the fault code. Important, more so with today's vehicles, performing a reset that cleared may not clear the MIL and eliminate the D rate. And you guys that work on this stuff, you know that actually is happening. There's a possibility that the conditions for running the diagnostic, the trips, have not been met for clearing the fault code and associated D rate. Fault code may clear, but the MIL lamp could remain on and the rate still active. Our world is a little bit harder, especially with all this D rate stuff and everything with the DPFs and SCRs. Follow his example. condition for setting the fault code, an internal circuit error has been detected in after treatment outlet knock sensor. What's the action taken when fault code is active? ECM illuminates what? The amber check engine lamp and or malfunction indicator lamp immediately when the diagnostic runs and fails. Engine torque will be reduced after 10 hours of engine operation with the fault code active. Vehicle speed will be limited to 5 miles after 40 hours of engine operation. And that's our rule, guys. The condition for clearing it, validate the repair, start operate the engine to raise exhaust temperatures. You can do that by either driving a vehicle. Hey, how about initiate that stationary check, get it up fast. The exhaust gas temperature after treatment outlet knock sensor must be above 302 degrees before sensor can run its internal diagnostics. Fault code status displayed by service tool will change to inactive. ECM will turn off the amber. For OBD engines, the ECM will turn off the MIL after 3 consecutive trips where the diagnostic runs and passes. The reset of faults command on your electronic service tool can be used to clear active and inactive faults as well as extinguish that. So what is a warm-up cycle? Again, it's in your handout here. I'm going super fast. So I just want to go through this few sets of slides. If you can bear with me for a second. All this is showing you how far we've come. This was in the day, okay? You see it, model 2000, okay? And this is when OBD first started to come aboard and all this stuff. And some of the scan tools allowed us to get into heavy duty without having to get specific. So this one had the amber check engine light on, red stop engine warning on. I hooked it in the day. This was my OTC. I used to be a OTC contract trainer, hooked up on the J1939 side, basically hit the enter button, scroll to diagnostic codes, enter. This time came up with a communication error prompt. Why was that? So I had to get out of there, scroll now to my older. Oh, gee, it's an older, it's the J1708. So I hit the enter button in here, highlighted 128, hit enter. This time, communication was established. Now I went to scroll down to diagnostic codes, okay? And I came up with a engine shutdown warning. ECM is trying to protect the engine. And it was some information, okay? So now I went into the parameters, and in the day, gee, we didn't have all the parameters I would have liked to have. There was nothing really about the coolant sensor, but we got enough codes to kind of jump in and go find a direction, So all I did was do some basics, and I didn't have to do this. I did this more or less just to shits and giggles, try to verify things, hooked up my meter, okay, found my wires, we're working a 5-volt reference. The coolant level was very low. Normally, I would just fill it and decide, hey, there it is. There's your problem, just no different than today. But I wanted to also get a little bit more information. So with the reservoir empty, makes it easier, make sure that the sensor is actually working. I want to eliminate comebacks. So I back probe, got my readings, continuity and all that stuff. Then I switched my leads, and it's in your handouts, okay? This is no liquid present. So all that was required wire drain. Well, if you didn't have one, it's a simple enough circuit to figure out what's going on. Now, this was the thing. So that empty reservoir started to fill, DVOM still hooked up. And guess what? When the coolant level touched the sensor, voltage change indicate, I call it liquid present. Now I am satisfied that vehicle is going to go down the road. Definitely it's got a leak, no doubt about that, but I'm heading away from the coolant sensor, so that's what it was all about. So real fast before we get out of here, G and I are doing a AC. The first one we did in July worked out great. We're doing another one on August 27th and 28th over here. Okay? It's combination class. We're going to do hands-on, whatever vehicles I got out here. I'll hook them up and we'll go through it. And I realize summer is almost done, but you know what? AC is year-round, especially when you go into defrost mode. If there's any questions, I'm sorry that, Jim, OTC, me too. I love it. I love it. Those were good days, weren't they, Jim? Yeah. Then a couple of times Steve Sack and everything, I mean, it was great. It's been a long, long time. We definitely got history here. But uh, anyway, if you got questions, shoot them out. I know we're running late over here. Let me get the next slide. Before you go, do me a favor, kind of whatever way, hit that bar, the little QR code over here, and uh, hit the QR. Just give a little, hey, yes, it didn't work. I'm gonna cut you guys out here. I'm sorry it took me so long to get through this, but again, I want to be as thorough as I could within a 1 hour thing. So thank you, everybody. Thank you, everybody, again for coming on board. And I will get this recording so it'll go back on YouTube and you can revisit it again. You know, so I'm seeing all the little thank you. You know what, guys, though, you have no freaking clue what those thank yous mean to me, and working all day in a freaking shop and doing all this stuff in the evening, putting stuff together. This keeps me pumped up. And if you guys ever want any other like the brake trainings and stuff, just get a hold of Dorman or whatever, GE and Doreen. We'll put it together. I think I'm due to go to Pennsylvania soon and everything. So thank you again. And I think I'll give it a minute so I can actually see the scrolling, and then we're gonna stop the recording. So nice, very nice. All you guys are saying, have a good afternoon. I hope your day goes great too. And like I said, it's OBD2, milk it, milk anything you get. So